PEMDAS, parentheses, exponents, multiplication, division, addition, subtraction. In number one, I don't see any parentheses or exponents, but I do see multiplication. All right. I also see division. I also see addition, and I also see subtraction. All right. So when it comes to multiplication and division, we think of those interchangeably, and we work from left to right. Okay. So these two operations would have to happen first. 24 divided by 6 is going to be 4. I'm going to leave the plus 4 as is. Negative 48 divided by 6, and then that result would get multiplied by 8. So you could do that all in one shot if you want. Negative 48 divided by 6 is 8, times 8 is negative 64, so minus 64. All right. So then addition followed by subtraction, only because addition comes first in the sequence. All right, 4 plus 4, 8. Phone's going nuts here. 4 plus 4 is 8, minus 64. So 8 minus 64 is going to be 56, negative 56. All right, so just checking that on Desmos, 24 divided by 6. Now, the thing about Desmos is that it's not going to use a division symbol. It's going to make it a fraction, so you just have to keep that in mind. So plus 4 minus 48 divided by 6 times 8. All right. So it'll carry out order of operations. The only thing is it'll look a little bit different. All right, and that's fine. All right. On the TI, put it right here. I don't know if there's a good place to put it. Let me get rid of this stuff. 24 divided by 6. Again, it's going to bring the slash instead of the division symbol, but that's okay in this context because it kind of looks similar enough that you can get away with it either way. Divided by 6 times 8. Just make sure I typed in everything the way I want it. And enter. And there you go. All right. So you get what you need using the calculator, and that's perfectly fine. But we do want to have a handle on order of operations because when we work with symbolic expressions, all right, so letters instead of numbers, it's going to get to a point where if you don't know the order of operations, you're gonna find it to be more difficult. All right. Number 2, we have parentheses, we have exponents, and all the other stuff as well. So I'll start off with the parentheses. So innermost in the parentheses, we have a 4 minus 2, so I'll take care of that first. I'm going to leave everything else as is. All right, so it's kind of annoying to rewrite everything just to change one little aspect of it, but you know, it's a organizational strategy that I use, and it's one that works. All right, then we're going to go for exponents because we're still living within the parentheses, even though it's a square bracket. It's still a type of parentheses, and in fact, they call it PEMDAS. It really should be FEMDAS because the F would represent fencing, which is the different forms of parentheses that you could have. Square brackets, squiggly brackets, and so on. All right. So inside the square brackets, we have all of this stuff going on, but inside all of that stuff going on, we have exponents. All right. So 10 minus square bracket, negative 5 times 2 squared, which is really negative 5 times 4. We're still living in the square brackets, so we tackle the negative 5 times 4, which is negative 20. We can release the negative 20 from the square brackets if we distribute or multiply through. It's not really distributing because it's just a single term within the bracket. multiplied by the -1, and we would have a positive 20. So 10 plus 20 would give you the 30. All right. Desmos handles this, and so does the TI very well. All right. The thing is, you don't have to use square brackets. Those are just kind of visual distinguishing characteristics. You know, it's just for our purposes. All right. You could use parentheses and even more parentheses if you want. So I'm going to write it with parentheses because I don't want to have to go looking around for square brackets. And sometimes, depending on the technology, sometimes square brackets are interpreted differently. So you never know. All right, so don't take the chance. Just use regular parentheses. All right, 10 minus -5 in parentheses. Then another set of parentheses, 4 minus 2. Close them up, square it, then close it up again, and you get your 30. All right. On the TI, it's going to be the exact same thing. It's just you're looking. Oh, sorry. On the TI, it's going to be the exact same thing. It's just you're going to place everything in slightly different locations. So 10 minus. Oh, and also, I got to be fair about this. With the TI, it's annoying because you have the difference between the minus and the negative sign. All right, you got to know when to use what. All right, so 10 minus parentheses. This is a -5. All right, because you're not subtracting this 5 from anything. It's just a standalone value of -5. So use the negative symbol. Parentheses 4 minus 2. Close it up and square it. Power of 2 right next to the comma. Close it up and then hit enter, and you have your 30 that way. All right. So either way, it's not bad. It's just there's just a learning curve. Let's just put it that way. And then the last one. I mean, I don't think the last one brings anything more to the party than the previous ones. So I'm just going to pop that right into the calculators. 24 minus 3 cubed divided by 9 times 7. Close it up. Raise it to the 4th power. Minus 6 squared divided by 4 plus 2 cubed. And you get an 80. Oops, pen's not working for some reason. Oh, there it is. All right. Now, the next set of problems are kind of tricky. I mean, they're very tricky. I'll tell you that historically, when we have taken a test on this unit in the past, it's only been this particular type of question that have tripped people up. Everything else has been pretty straightforward. They'll get everything else done on the test and then spend the rest of the class period trying to figure out this problem. Not because it's conceptually overly difficult, it's just because it's tedious, and obviously, I mean, part of the definition of tedious is it takes a while. All right, so insert parentheses to make the statement true. All right, so if I look at this expression here on the left-hand side, I want to make this have a value of 15. The first thing I would want to check to see is if it already has the value of 15, if it as written, you know. So I'd write 3 times, or type in 3 times 4 plus 4 squared. Then I'd pop in and divide it by 4, and that's 16. All right. So it's not quite the way I'd want it to be. All right. So I'd want to be thinking, all right, if I'm going to put parentheses in it, remember, order of operations, we got to be thinking about what the first operation would be under the current circumstances. All right, so based on what you see here, the first operation would be 3 times 4. All right, so what we would want to be doing by inserting parentheses is make something else the first operation. All right, by putting in parentheses, I'm saying I don't want the 3 times 4 to, oh, I'm sorry, not the 3 times 4, the 4 squared. I don't want the 4 squared to necessarily happen first. All right. Or perhaps I don't want the 3 times 4 to happen as early as it does in the process. All right. So I would be thinking to myself, all right, what happens last? If I were to carry this out using order of operations in the way that it's currently constructed, what would happen last in the process? All right. The addition would happen last. All right, so let's see if we can come up with a way to make the addition happen first. All right, so if I do that, or if I wanted to do that, I might do something like this. All right, may not work. If it doesn't work, that's fine, but you don't know until you try. All right, so 4 squared is 16 plus 4, all right, because within the parentheses, we've got to carry out all that stuff first. 4 squared is 16, plus 4 is 20. Rewrite everything else. 3 times 4 is 3 times 4. 3 times 20 is 60. Divided by 4 is actually 15. It works out. All right. Now, I got lucky because my first suspicion actually kind of played itself out correctly, but that may not be the case. All right, if that didn't work, I'd try something else. All right, so let's take a look at number 2. In PEMDAS, again, addition subtraction would be the last thing that happens. So perhaps I want to try to make it the first thing that happens, or among the first thing that happens. All right, so maybe I'm going to put parentheses here. But I got to be reasonable about this. Let me do what I did in the last problem. Type in the original expression just to make sure. I mean, because it could be the case where I just do boop. Maybe it's a trick question. Maybe it's fine just the way it is. So let me type in the original expression. All right, that's 28. As is. All right, I need to make that 60. All right, I also want to be thinking about, all right, how could that play out necessarily? I mean, if you think about dividing, right, the act of dividing is going to make a number smaller. That's probably the only way in which this number gets as small as it does. 28 isn't that small, but smaller than 60. All right, so maybe if we figure out a way to divide by less, then maybe that'll do the trick. All right, but going back to the earlier strategy of taking what would happen last and make it among the first things that happen, we'll see if that plays out. All right, so in the parentheses we'd have 1 plus 8 gives you a 9. That's not going to play out. All right, 5 times 4 is 20, divided by 9 is not going to give you 60. All right, so the strategy that worked in number 1 isn't going to work itself out here. All right, now it just said insert parentheses. It didn't say insert parentheses around 2 items. Maybe it's 3 items. All right, that's a possibility. Maybe I want to do something like this as a possibility. However, we run into an issue there where that would have been among the first things that would have happened anyway. All right. So 5 times 4 is 20. Then divided by the 1 would give you also a 20. Plus 8 would give you 28. That's not going to be of any help. All right. So still working our way backwards through PEMDAS. We don't have any subtraction. Division would be among the last things that happen in the order in which it happens. All right. So we grouped these two. Maybe we want to group these two to make that happen among the first things. All right. So in which case that would give you a 4, but still just working from left to right, that's still going to give you a 28. All right. Multiplication would be the next last or later operation to happen. exponents and so on, but then before you know it, you're back to the beginning of the process, right? Sometimes it's a matter of just kind of moving some things around and seeing what happens, all right? So we tried putting parentheses here. We tried putting parentheses here. Maybe we'll try here and see what happens, all right? Because I look at this and I say, all right, well, how can I get to a 60? Well, thinking about multiples of 5, 5 times 12 would give me a 60. So perhaps this group of 3 would end up being equal to 12. If it does, then I'm good. All right, I won't know until I try. All right, so in the parentheses, I have the exponent, so that's going to become 4 divided by 1 plus 8. 4 divided by 1 is 4, plus 8 is going to give you the 12. So 5 times 12 is going to give you 60. All right, so that plays out. But sometimes it's a matter of failing a few times in order to succeed later on. All right, number 3, you think about it again in PEMDAS, addition, subtraction from left to right would be among the last things that happen. I don't have multiplication or division here, so I'm not worried about that stuff. I don't have exponents. So really all I'm trying to do is upset the order of operations here. So if I can make this equal to an 8 somehow, I'll be in good shape. Now, sometimes it just kind of jumps out at you, like right out of the screen. I mean, if you want, again, like I said, just type in the original expression and see what happens, because sometimes it just kind of gives it away, But also I'm thinking to myself, all right, if only I could keep this 8 just the way it is. Thinking, 3 classes ago, the identity relationship. If this could stay put, that would be great. Which would mean that all this other stuff would have to be equal to 0. If all this other stuff equaled 0, that would be perfect. So let's see if they actually equal 0. 7 plus 2 is 9 from left to right. All right, 7 plus 2 is 9, minus 9 is equal to 0. 8 plus 0 is equal to 8, so we're good to go. All right, so it may not pop off the page at you, but with experience, it starts making a lot more sense. All right, the last one, probably one of the more intimidating looking ones because of the bigger numbers. We have 32 divided by 4 plus 16 minus 4 times 3 equals 4. All right. So again, it's the strategy to try to upset the order of operations. All right. So we don't have any parentheses. We don't have any exponents. We need to put parentheses in. Next up would be multiplication division from left to right. So we're thinking about the last thing that would happen. It's this operation right here that would be last. So try to make that first. The way you try to make it first is put it in parentheses. See what happens. However, always keep in mind that we're trying to get this result. We have something to start with. That 32 divided by something needs to give you a 4. All right? So 32, perhaps, if we're lucky, all of this stuff will amount to an 8. If it does, then we'll have the 4 that we're looking for. All right. So, but you don't know until you try. All right. So keep that in mind. So 16 minus 4 is going to give you a 12. Working from left to right, we're going to carry out this operation, and this operation is going to give you an 8. So we're nowhere near it. All right. So that didn't play out. All right. So my second possibility is maybe we'll get lucky and this will amount to an 8, but you never know. If it doesn't work, we'll have to try something else. 4 plus 16 is 20. Well, actually, let me not get lazy here. Negative 4 times 3 is negative 12. I'm going to write all the steps. 4 plus 16 is 20 minus 12 is going to give you the 8. Then we have the 32 divided by 8 is going to give you the 4. All right. You could see how this could be pretty challenging on a test, right? Because if you don't guess right the first time, and I'm saying guess, but it's not really guessing. It's just kind of having the number sense to look at it and say, all right, where am I starting and where do I want to end up? All right. And in a lot of cases, it's a matter of really looking at that first number. The first number along with the operation that follows it, and saying, how can I get from that first number using that operation to the last number, or the number on the right hand side? All right. Yeah. Yeah. So if you could pick up on that, then things tend to start working themselves out. All right. Use the order of operations in a digits 2, 4, 6, and 8 to create an expression with a value of 2. You may add exponents and or negative numbers as needed. So answers on this one vary because, I mean, anybody can come up with anything. All right. It's not the kind of question that you'll see on a Regents exam. What they'll say is explain how, or explain the thought process that one would use in order to create an order of operations expression to give, like basically this question, but with the explanation part of it. All right. So I would start off with the numbers 2, 4, 6, and 8, but if I want to use them appropriately, I would want to make sure that there's some ordering involved. Right? I'd probably start with the bigger numbers. So 8, 6, 4, 2, maybe in that order. All right. And it's got to have a value of 2. I'd be thinking about, all right, well, what would I get if I added some things together? All right. If I added these two, I'd get 14. All right. If I added these two together, all right, that would give me a 6. All right. That gets me an 8. All right. It's not quite where I'd want it to be. So what I could do instead is say, all right, well, maybe I don't want to do an addition there. Maybe I want to take this 2 and make it a power, in which case I'd get a 16. Looks good. Then, all right, well, I want a positive 2, so let me switch the order. And subtract. All right. Now, you may use exponents and or negative values as needed. Didn't say anything about parentheses. All right. Didn't say I had to use addition. It just says I may use these things, all right, as needed. So I got a lot of wiggle room here. All right. So 16 minus 8 is going to get, if I leave it like this, we're going to have a problem, right? Because 16, I'll just kind of illustrate. 16 minus 8 would give you an 8, plus 6 would give you, so you're back to a 14. So it didn't say I need to put parentheses in there, but I want to put parentheses in there because I want this to be a positive 14 so that when I subtract it, I'm taking 16 minus the 14, that'll give me the 2. All right? So if this looks like trial and error, then I guess I'm getting the point across because that's exactly what it is. All right? We don't want to necessarily go in thinking that every problem is going to have a defined set of, okay, follow these 5 steps and you'll get the answer. Sometimes you have to play around with the numbers and see what happens. All right? I can leave the check there. But this would be an answer. All right? There's plenty of other answers that are out there. This is the one that I came up with. All right? So on the next